To understand why we created MRTK, we need to understand a bit about the history of mixed reality content development. Back in 2016, in the original HoloLens 1 days, developers had pretty limited choices for building content. While we're used to using Unity today to easily build immersive XR experiences, Unity didn't have nearly as robust support for these technologies back then. And as a result, it was up to us to build support for devices like HoloLens and Windows mixed reality headsets. We had to build nearly all the tooling, the input functionality, and interaction systems ourselves. And while we were doing so, we realized that there are a common set of problems that every developer runs into when making an app for AR and VR. And so we decided to make a toolkit of solutions to those problems and made it cross-platform to support the entire XR community. And that's how MRTK was born.
Welcome to the Global XR Conference. And in this session, we have Curtis from Microsoft. Welcome, Curtis, who is a senior engineer working on MRTK, correct? With a session on MRTK. So I'm really excited for your session.
Happy to be here.
Thank you so much for being here. Let's, well, I would say let's just start.
Works for me. Hi everyone. Thank you for coming. Welcome to my session on deploying everywhere with MRTK3 and OpenXR. Just quickly a little bit about myself. I'm Curtis Evely. I'm a senior software engineer at Microsoft on the MRTK Plus middleware team. I've been involved in MRTK, HoloLens, mixed reality generally for the last 8 or so years. If you just saw that little video at the beginning from my coworker Grace, starting with the original Holo Toolkit and the original Holographic Academy, working alongside the engineers at Unity to make sure our platform and devices work well. Then on to MRTK2, where we started to put that eye on cross-platform and more than just our devices out there in the industry, which led to working with Unity to adopt and implement OpenXR, which is what a good portion of this talk is going to be about, which directly led to sort of where we are today, MRTK3, taking advantage of the work we've done and our friends have done around the industry to make cross-platform XR a much more just achievable goal. I spend my time currently working across MRTK3, the mixed reality OpenXR plugin for Unity. If you've heard of that, I'll talk about that a little bit later as well. Just generally thinking through the whole stack, identifying places where it makes sense for MRTK to add value, or where the greater value might be in pushing some feature or some integration lower in the stack, whether that's mixed reality OpenXR plugin, Unity's OpenXR plugin, Unity generally, OpenXR generally. Just kind of have fun thinking about the whole thing. I guess just to get started, just some background on what is MRTK, just in case you're here and you just aren't familiar with MRTK. Basically, it's we like to think of it as a collection of my slides are going. Basically a collection of UI building blocks and developer tools that just kind of help you, get started in XR development. Sort of like Grace said, back, a while ago now, right? There wasn't much out there, and we sort of had to build a lot of the groundwork and a lot of just the sort of helper scripts that we saw, whether we were building like Holographic Academy courses and we were trying to teach you, in HoloLens 1 days, gaze, gesture, and voice, right? And we just found like, everyone needs to, have a gaze pointer or these days kind of like a hand pointer and that sort of thing. And just kind of making that really easy so that you don't really have to think as much about that part of it and can really focus on what makes, your application or your experience unique, right? And starting with MRTK2, we really had an eye for cross-platform, and that's strongly continued on to MRTK3 and was kind of one of the guiding decisions for why we decided to move on, sort of start the transition from MRTK2 into MRTK3. We also, just like to say, the MRTK provides kind of a nice sort of fast time to value, is sort of how we put it. Just increased development velocity via in-editor tools like input simulation, which is what's happening on the video here, as well as the MRTK build window, which is on its way to MRTK3. A community member recently opened a PR, and we're working to bring it in as a package. And you may have noticed that video was actually MRTK2. I need to re-record that video, but I believe everything we showed in that video is doable today in MRTK3, and also extensible, right? In MRTK2, we shipped a set of extension points, data providers, and the aptly named extension services. In MRTK3, since we're building our own tooling on top of some of Unity's extension points now, like XRI, the XR Interaction Toolkit, we're essentially extensible by default, sort of working to adapt our components to the general abstraction layer, make it so you can kind of mix and match MRTK, XRI, your own custom components, whether those are interactors, interactables, kind of various pieces of the interaction stack. A quick brief history on just the toolkit in general, in case you've run into a previous iteration of MRTK and might not know it or might remember it, but are curious where it kind of fits into the story. Originally, January 2016, the Holo toolkit was kind of around when I believe we first started pushing it to GitHub. Generally, a collection of scripts that we found useful both on internal projects like the Holographic Academy, things like Robo Raid and Fragments, and basically just helping people, helping kickstart like HoloLens 1 development, really. That led to more accessible VR headsets and that sort of thing joining the market, and we wanted to help support that. So that kind of led to MRTK2, MRTK V2 in 2019, an evolution, adding support for more than just HoloLens 1, including HoloLens 2 at that time, and various VR headsets targeting things like OpenVR and the Windows Mixed Reality runtime, which then sort of led us to MRTK3. Instead of targeting Windows MR and OpenVR, now we can kind of just target OpenXR and get all of that. So we've been working really closely with our friends at Microsoft that work with the rest of our friends in the industry on the OpenXR standard and the various OpenXR runtimes out there. And this just kind of became a good convergence point for us, where a lot of the things we had to think about and had to do in Holo Toolkit and MRTK2 started to be kind of unnecessary for us to do. We didn't have to do as much of a platform abstraction because OpenXR started to handle that. We didn't have to do as much of our controller mapping profile and input actions because Unity's new input system does that. I'm sort of getting slightly ahead of myself here, but that kind of leads me into this picture, which is sort of our a general architectural layout of kind of the interaction, and a little bit more kind of the spatial and interaction stack of MRTK3. Kind of at the heart of it, you can see kind of that mint green color is three sort of Unity pieces. The XR Interaction Toolkit, which I'll also refer to as XRI. Unity's new input system. I don't think I'll ever stop referring it to the new input system, because it was always going to be, the new input system for so long. Now it's here. It's technically, I guess, no longer new. The old one's just legacy, but kind of their new, input action mapping based input system, as well as sort of Unity subsystems, whether that's just kind of the base definition of subsystem, where we have created our own kind of set of MRTK subsystems that provide sets of data that either MRTK3 finds interesting, or you as a developer might find interesting, as well as Unity's set of XR and AR subsystems, which you might be familiar with if you've used Unity's AR Foundation for, the AR Mesh Manager is driven by an XR Mesh subsystem. And so in MRTK2, we sort of did some talking directly to the subsystems. But for MRTK3, we're really recommending just kind of, talking directly to Unity's AR Foundation layer. Because AR Foundation is, also just cross-platform by default, you're able to get, meshes and planes and anchors and that sort of thing across a variety of devices. So yeah, MRTK3 and MRTK in its new form, right, has really become an extension of Unity's XR platform. We've re-architected it from MRTK2 to give users, developers, everyone more control over your project, and just trying to do things a little bit more. We always hear do things a little more like Unity-like, right? Like MRTK2 and Holo Toolkit to some extent, right? Because Unity didn't necessarily have their own sort of ways of doing some of these things. We kind of had to create it on the fly, or maybe something in Unity didn't work quite the way we expected it in XR. So we had to sort of rework it a little bit, but Unity's in I think a really great place today as far as their XR support. And we've just, like I said before, this became a really good convergence point for us to build on where we are as an industry today, as opposed to where we were 6 years ago. We also, very obviously build on that big purple bar at the bottom. OpenXR, both Unity's OpenXR package, they ship kind of a package that just has sort of core OpenXR support, rendering and head tracking and a decent amount of the input tracking and that sort of thing, as well as Microsoft's mixed reality OpenXR plugin package. I'm going to focus mostly on the OpenXR and a little bit of the input system part of the story today. I'm going to talk a little bit less about XRI, because you should go attend my coworker Finn Sinclair's presentation later today, which is cross-platform XR interaction with MRTK3, where he will go into XRI and kind of our usage of it a lot more. So yeah, OpenXR. What is OpenXR? In case you're here and you haven't heard of OpenXR, their mission statement's on screen. You can read that. But really, what this means for you is a sort of consistent deployment pipeline, supporting deploying across vendor-specific runtimes without juggling different API calls, right? Like if you've ever looked at some old MRTK2 code or written your own code where you're like, if I'm on UWP, call into the HoloLens API. If I'm on Android, call into the Quest API. Now for so many features, there's just kind of a consistent single API, and you start to care a little bit less about which device you're on, and more just about which features available. You kind of don't say like, if HoloLens do hand tracking, you more care like if hand tracking is available, do hand tracking, and you care a little bit less about the specific device you're on, and more about the specifics of the device you're on, I guess. So yeah, so where does OpenXR bring value into Unity and MRTK? Back in the old days, MRTK2, we had we had a variety of support. We had support for the Ultraleap, support for Oculus, support for OpenVR, support for Windows MR. All of those had their own plugin packages. Some of them had their own Unity packages on the asset store. You had to pull them all in, configure them differently. Sometimes one of them wanted some setting configured some way, another one wanted another configuration another way. We had to do kind of a lot of work in MRTK2 to adapt to when you imported one or the other. If you maybe had more than one imported, we did something different. It just kind of became a bit of a headache sometimes, and probably one of the biggest pain points we heard was, hey, I imported the Oculus package like you told me to, and nothing works. And then we had to figure out why, and because of the way we had to integrate it, there were a couple different points where things could go wrong, and it just became a little bit more complicated than it needed to be. And that led to MRTK integration scripts, like kind of I was just referring to, data providers for each platform, controller mappings for each controller, which do still exist today, just not in MRTK. We use Unity's input system, which is nice. It kind of it's I will say quite a bit more extensible than our version of it, and it's just much nicer for doing things kind of in Unity and in a way that various other Unity packages take advantage of. Just kind of the standard way of doing input in Unity is now much better. So now, one pipeline for all. Core support just sort of works out of the box. If you just kind of want head tracking from your HMD and maybe hand tracking, you just kind of all of that has sort of head tracking has Unity standard ways of doing that. Hand tracking, we've got pieces in MRTK that just kind of will do that in a standard way, regardless of the device you're on. And it's just much easier, greater device compatibility, and sort of like I've been saying, the platforms and runtimes in Unity handle the fundamentals, and MRTK can just kind of focus on its strength, which is additional sets of developer tooling and a very sort of robust interaction UI UX stack and framework. So yeah, a couple of things you get as cross-platform. I'll talk about this a little bit more when I talk about our actual integration into Unity. But the big one is hand joint tracking. You get a set of standard interaction profiles for controller and hand input, which kind of become these profiles that you say I've tested with one of the WinMR controllers and maybe an Oculus Touch controller, and you kind of assert that fact. And then the runtimes will kind of adapt based on if the users of your app have actually attached some other controller that you didn't test on there. They're able to kind of intelligently remap at runtime, and your app should just continue to sort of reasonably work as far as input is concerned. So yeah, I'll start talking just a little bit about the mixed reality OpenXR plugin. So like I said before, Unity ships their own OpenXR plugin, and that contains the most of the sort of OpenXR loaders, just for telling the devices to start OpenXR, right? As well as a set of core interaction profiles, which I'll talk a little bit about the specifics of that later. But for sort of vendor specific pieces, this becomes potentially where you may end up installing a couple of packages depending on the runtimes you expect to run on, because while there is sort of the core OpenXR spec, different companies can add device specific or runtime specific features on top of that, and in order to integrate that into the engine, Unity has nicely exposed a set of extension points, and we build on all those for the mixed reality OpenXR plugin. Before I talk a bit about what's in the plugin, just a quick note on how to acquire it. If you've installed MRTK3 at all, or MRTK2 in the last like a year and a half or so. I think it's been a little while. You'll acquire it via the mixed reality feature tool. It's under platform support. We actually just released the 1.6.0 release yesterday, I think, or possibly Wednesday, bringing some improvements to holographic remoting, some new spatial anchor features for HoloLens 2, and a whole new sort of project settings validation flow based on Unity's new project validator hooks, and more. So if you're going to go check out MRTK3, you should also check under the platform support dropdown and check out the latest version of the mixed reality OpenXR plugin. So as far as configuration, right? Like I said, if we're juggling the different platforms, you used to have, in this example, Oculus and Windows Mixed Reality. Now it's kind of just OpenXR and a set of features. You'll still, probably have sort of operating OS specific settings, right? But you start to have fewer kind of device specific settings, which is nice just to sort of expand that a little bit. And yeah, the kind of big one is, there's no more like, check, Oculus for this build and then check like Windows Mixed Reality for this build. You can now just check OpenXR and a set of settings that you assert like my app, wants to use, and then build and deploy. And based on, your user's default OpenXR runtime on their machine, that's what will start up and just work with their device. Let's see. So in the mixed reality OpenXR plugin, the sort of set of features we ship it's a combo of Microsoft specific extensions for things like the hand tracking mesh, spatial meshing, spatial anchors, holographic remoting, things you've come to expect from, a device like the HoloLens. And we also ship a set of cross-vendor extensions. I guess the main true cross-vendor extension today is hand joint tracking and hand joints motion range. For those of you who don't know motion range, it's useful for when you're trying to render, let's say a motion controller model and a hand, and kind of a hand provided by the runtime at the same time. The runtime can provide kind of a flat hand, or one that kind of looks like it's holding the controller. So it's very visually interesting. But generally, the cross-vendor hand joint tracking extension is supported by HoloLens 2, Ultraleaf Sleep Motion, MetaQuest. Snapdragon Spaces is one that we've recently been looking at, and we've been working on getting MRTK3 working there. And one thing that I've also started sort of looking into in the MR OpenXR plugin is where we can combine vendor-specific extensions into a singular API surface for you to use, right? And so the I think it was the 1.5 release. We added support for the Quest runtime controller models on top of the Microsoft runtime controller models. So although there isn't yet kind of a cross-vendor OpenXR extension for that, we're able to kind of combine two of the existing ones in the MR OpenXR plugin, so that as far as you're concerned, you're just saying, hey, is there a model? Cool, give me the information and I can render it. And now that API will work across Windows Mixed Reality headsets and Quest headsets. Cool. So now I'm going to just dive into a little bit more of the specifics of Unity's extensibility hooks for OpenXR. So pretty much everything I talk through here are components and extension points that we have built on in the Mixed Reality OpenXR plugin, and that you could also build on if you find yourself, needing to add support for a specific runtime feature that just hasn't been integrated into Unity yet, or you might be the developer of an API layer or your own runtime, and you're trying to get your loader into Unity or get a specific feature into Unity that your runtime supports. This is how you would do it. So essentially, Unity's sort of OpenXR support is broken down into features and feature sets. So a feature can represent a single OpenXR extension, But we often also use them to kind of represent a set of like logically grouped extensions, right? So if you see in the screenshot here, our hand tracking feature plugin, and the screenshot's actually out of date now, funnily enough, but we request the ext hand tracking extension, which is that cross-vendor hand joint tracking extension, and we request the Microsoft specific hand tracking mesh. We also now, I was just talking about hand joint motion range, request the motion range extension as well. And so it kind of allows you to either expose like very specific extensions to the developer, or if you expect them to just kind of want a scenario enabled, like hand tracking, just give me all of the features and data for hand tracking, right? Hand mesh, hand joints, hand whatever. That's kind of the path we've taken with the hand tracking feature plugin. So yeah, you'll see we kind of inherit from OpenXR feature plugin. That's kind of our wrapper around Unity's extension point, which is OpenXR feature, and then OpenXR, the OpenXR feature attribute at the top there just gives Unity a lot of like metadata and information, configuration information about this feature, so they can hook it into their UI and properly, include certain, DLLs or scripts on deploy. So then, yeah, feature groups. Feature groups become just a step above, right? Like a slightly larger circle, I suppose, right? Of sets of features, right? So we have like a Windows mixed reality feature group that just kind of says, if you're targeting like one of our Windows mixed reality headsets, we have in for UWP we have a HoloLens 2 feature group. You could say, just turn on everything that you think is interesting and relevant to me for HoloLens 2. You can just check that box, and it'll turn all of the interesting features on for you. Just kind of an easy way of getting started and turning a bunch of things on at once. And then as far as input and interaction is concerned, interaction profiles are the interesting piece, right? If you remember or have used MRTK2, this becomes kind of the layer below the MRTK2 controller mapping profile, right? We had like a set of specifically defined controller definitions, we called them, right? For any sort of any physical hardware controller. Those are now defined and integrated into the OpenXR spec, which is great. And then you can bring those into Unity as well. Like I said, Unity ships a default set like Oculus Touch, the Microsoft Motion Controllers, the Valve Index. We added another one for the HP Reverb G2 controller in the MR OpenXR plugin. You could add, if your runtime or device supports other interaction profiles, there's extension points for you to add them and hook them into the system, which is nice because there are also extension points to hook them into Unity's input system and the sort of the input action mapping set. And that kind of stack there, right? Like the interaction profiles into Unity's input system, into the action mappings, is a pretty full replacement and a much more extensible and I'll say polished replacement for MRTK2's controller mapping profile, which was usable and it worked, but was always a piece of not struggle, but people would always say, I want to add a new controller, I want to do this and that, and it was always just a little bit more difficult than it needed to be. Unity's input system and sort of controller mapping stack is we found to be really nice and really usable. Anyway, so when do I need an interaction profile? I'll go back real quick. If you notice, I have sort of all of them in the screenshot. We tend to recommend you don't necessarily do that. We often recommend that you only enable the devices that you've sort of actually physically tested with, and that that the specific buttons are mapped to exactly the actions that you want to happen. And what that does is it kind of allows the runtime to do some intelligent remapping for you automatically when users connect to other devices to your app. So that tends to be kind of our recommendation, and that tends to be our recommendation. Cool. So that's, yeah, a little bit about Unity's kind of OpenXR extension hooks. Real quick, I will jump into the input system. So I've been talking about the input system and talking about kind of what you can do there. And I guess now I'll just kind of show you a little bit more. So yeah, like I've said before, it's very similar to MRTK's controller mapping profile. Conceptually, it's almost flipped, I guess, right? Like MRTK2 put an emphasis on here is a controller, map its buttons, right? Unity's input system puts more of an emphasis on like here are the mappings, assign buttons to them. So it's yeah, slightly flipped, but I think very usable. It kind of puts an emphasis on almost completeness, right? Like if you expand one of the input actions and you notice, oh, I meant to map 3 different controllers here, but there's only 2 mappings. You know that something's wrong, right? Whereas in the MRTK2 style, you'd have to like click on each controller and be like, oh, did I map that button to some action? And it becomes a little bit less obvious when you might have left one action off of a specific controller and that sort of thing. And then these actions directly feed into XRI, directly feed into MRTK3, directly feed into actually kind of a broad set of Unity components because it is their sort of core, a core feature of their input system now. In the mapping dropdown, you'll want to look for these like OpenXR definitions. They are currently populated only from the enabled interaction profiles in your OpenXR settings. We're currently working with Unity to try to figure out that flow a little bit, but currently, yeah, you'll turn on a specific controller in your interaction profile settings, and it will register the possible input actions and maps with the input system. And then those input actions get mapped to, like I said, sort of things in the scene, right? In this example, that is our sort of root XR controller. We have this articulated hand controller, just so that we can add this kind of context of hand joints on top of the base controller. And you can see we've mapped interactions like pose, position, rotation, tracking state, right? Select, activate, just various mapping input action mappings to the controller, so that regardless of the physical controller that is connected, that's then piping into the input system, which then compresses it into the input action mapping, which then sends it to the controller. The controller doesn't, the controller being this XR controller, right, doesn't really care where it came from. It's like, I don't care where the select came from, just tell me when I should be selecting, right? And then this drives our our interactors, like far ray, poke, grab, which then drive interactables when you're interacting with them. Cool. So yeah, so that's sort of the input system. Like I said, yeah, Finn's talk later. We'll talk a bit more about XRI and kind of the interactions that we use these for in MRTK3. And then I just quickly near the end wanted to talk about what about devices that don't support OpenXR. Kind of the main one is that we hear about it, right, is mobile AR, right, ARCore and ARKit. Because a lot of our integration is just based on Unity's XR SDK framework, you could technically use any of Unity's XR plugins. Including the ones for ARCore and ARKit. We want, we're putting very strong emphasis on the specific OpenXR plugin, just because we think that's the best path forward, right? It's the best path for developers. It's the best path for tools like MRTK that can just kind of target a specific consistent platform that will work on as many devices as possible. But we are sort of actively doing some work in making mobile AR work. It mostly works. There's just kind of a bit of configuration you need to change, and I'm currently working through like what we want to bake into MRTK versus what we want to kind of make a guide. But I did just kind of record this quick video the the other day, just showing our kind of MRTK3 example scene running on an Android phone. Please excuse my my very like inelegant one-handedness on here when I had camera in one hand and trying to interact with things on the other hand. I mostly kept things in focus, but you can see like just about everything in this scene is interactable, and it is just running MRTK3 on AR core. So that is something that that we're working to support. Cool. Let's see. Ooh. Oh, right. Running slightly out of time. I wanted to quickly try to jump out. We'll see if this works and run a quick demo. Sweet. Cool. So here's Unity. Sorry, Unity's over here for me, so I'm going to slightly look away from the camera momentarily. But here's Unity. This is the MRTK hand interaction example scene. This is the exact scene that I was just showing you on my Android phone there. Just quickly jumping into kind of, this is our MRTK XR rig. Under here, these are kind of the controllers I was referring to. And under the controllers is kind of where all the interactors are, right? So we've got the far array, whether that becomes a hand array or a controller array, the grab interactor, gaze and pinch for devices that support eye tracking. You can just kind of use your eyes to target and then just kind of pinch with your hands, as well as the poke interactor for direct interaction. And so we currently kind of have that split into right hand, left hand, and the gaze controller. And you could add other interactors to these controllers. You could add other controllers to these controllers. These are all just extension points on XRI. And our goal has been to use as much of, if not all of, the XRI kind of abstraction layer, make sure that our data flows in there in a consistent and reasonable way, so that if you are just using XRI interactors and interactables, any like mixture and match of XRI interactors, MRTK interactors, your own interactors, we want them to all be able to talk to each other and just kind of work consistently and reasonably. Cool. So really quick, now that I've given all of my devices enough time to fall asleep, let me try to just run a ever so quick demo. This is just, a little bit at the end that I like to do. That I like to do just to show off kind of for anybody who's tried to juggle devices in MRTK2, just to kind of show how much nicer it is in MRTK3. So I'm starting holographic remoting on this HoloLens 2 here. You can see on the screen, I've kind of pre-configured it with my IP address. I'm just going to go ahead and click Enable Holographic Remoting for Play Mode. What that does here is that this is just kind of the new remoting window. If you've done holographic remoting in Unity, you're familiar with that. That'll turn on kind of hand tracking and a couple other features. But then, let's see, maximize on play. Cool. If I hit play here and everything works, we should jump right into, here we go. Holographic remoting, I put my hands up. We don't tend to have these sort of joint cubes on by default, because when you're in an AR device, you can see your hands. I turned them on because for you guys, you'll be just seeing my screen, and I wanted you to be able to see that hand tracking is working. But I can sort of come up and everything's just slightly further away. But I can grab cubes, interact with things, push the buttons. I can bring everything a little closer. There we go. Now I can play the piano. And so, this is just kind of holographic remoting working on HoloLens 2. Then I will switch over. then quickly switching over to a Quest 2, enabling Oculus Link. Then in here, depending on your default settings here, my OpenXR runtime on my system is set to the Windows Mixed Reality one. But if you just go ahead and just kind of switch it to this Oculus one, that just kind of, and you have Oculus Link enabled on your device. Now I can hit play, and it will start up again. But this time, I am in my Quest, doing basically the same things. You can see we have these kind of nice rigged hands here. This is kind of what we tend to use on VR for when you don't if you don't have pass-through and you can't actually see your hands. Again, I left the cubes on just kind of for visual purposes for the demo, but this is the exact same hand joint API that we were calling when we were running on the HoloLens 2. We're just calling it now from a Quest. So yeah, that was just a quick demo of just kind of jumping back and forth between devices in the editor. And cool. So yeah, quick thing for MRTK3, we just released, or I think it was last week, we released public preview 12. So please, yeah, it was a pretty meaty release because it had been a little while since preview 11. But please go check that out. And thank you. There's some links on the screen, some URLs, both about getting started with the MRTK3 public preview and getting started with like the mixed reality OpenXR plugin and generally OpenXR in Unity. Also, before I go, I mentioned Finn's presentation earlier, but I didn't want to go without calling out another team member of mine, Nick Klingensmith, who's giving a StereoKit talk later today as well. So if you ever feel like you like more XR development engine options than just Unity, and you're interested in OpenXR, definitely give his talk a watch. And that's everything from me. So thank you very much for coming and attending.
Thank you so much, Curtis, for this really cool talk. It's so cool to see how far MRTK has come.
Yeah, it's
the crop platform. It's just awesome.
There we go. It's been awesome being kind of having worked on it for so long and seeing where we came from. Yeah, just kind of just HoloLens 1 in the Holo Toolkit days to kind of just like the growth of the industry as a whole and where we are today.
So MRTK3 is heavily based on Unity XRI. What does that mean for Unreal developers?
So we have a team member on our team who is who has been working on Unreal and has been working on kind of a version of like MRTK for Unreal. We definitely want to support Unreal for all of the MRTK3 features today, and historically we have had a much stronger emphasis on Unity, but things like Unreal and I just mentioned StereoKit are sort of always have always been in our plans, and we're trying to find the right way to support them all. But so far, just because most of what we hear has been Unity, that's kind of where we've put our focus so far. But we're always looking for opportunities to expand the community of developers who want to and who can use their existing experience with other engines in XR.
Nice. But so at the moment the feature set for Unity is much bigger.
Yes. Right? That's true. Yeah. At the moment.
Yeah, you're getting a lot of compliments from our audience. Here's Joe saying awesome work. And he also he has a question. When are we getting cross-platform underlay transparency?
Oh, interesting.
It's a very specific question.
Is that from talking about like pass through, or is that?
I'm not sure, Joost, if you're still watching, if you wanna expand on that in the comments. I'm not sure. Yeah, there's also on Discord, we also have some questions. Oh, wait, Joost says this is specific for Quest, so on the Meta Quest.
Yeah, that's actually something I've been looking at. It's something that we would, if we were to ship it, and this isn't something that like Meta has easily available for passive. Yeah, cool. Then yeah, I've been I actually, yeah, I have a version of this actually working in locally in the OpenXR plugin, and so we're kind of just figuring out the right way to potentially like ship that publicly. But that would definitely be, at least as far as the feature is concerned, something we would ship in the OpenXR plugin, and then something we could add stuff for in MRTK3. I know I've mentioned Finn a couple of times. I've had conversations with him where he wants like a button on the hand menu that's just like toggle pass through for like we are the MRTK, like let's do as many of the MR features as possible, and pass through is a super cool one.
Joost is very happy with your answer.
Excited. Yeah, cool. Yeah, I'll definitely reach out to you when I have some more information on that. There's some stuff that I'm working on, and just sort of we're working on internally. But yeah, I'll keep you updated.
Cool. Maybe there's some questions on Discord. Maybe you have time to jump into Discord later to look at them and see. There's a bit more general one. Someone uses a Mac as a development machine, asks if you can actually download MRTK3 through the Unity asset store, because he has trouble with the
Yeah, that is definitely a feature request we hear a lot for like the mixed reality feature tool, and something that we're looking into is right now it is Windows only, but absolutely we want to make sure we support developers on other operating systems. So that's definitely something that we hear a lot, and something we've been looking into. I don't have any specific timelines, but yeah. And then as far as the asset store, we've been trying to, because we want to ship our packages as like UPM packages, the new Unity package manager. We've been kind of not avoiding, but not necessarily leaning as closely towards like the old like .unity packages and then the Unity asset store, just because we found that kind of later in the MRTK2 cycle, when we switched to UPM packages, the immutability of those packages really just helps with consistency in support on our side, right? If we know that you're using this version, so none of your scripts have changed, right? When the asset packages just sort of go into your assets folder, sometimes things get changed, something gets deleted, something like it just kind of provides we found a more consistent developer experience, of course at the expense of us needing to be much more mindful of extensibility points and customization points, so that you don't have to go in and change our scripts, right? But that's kind of why we made that decision, is kind of consistency of experience and consumption. And I think theoretically Unity also does some kind of like assembly, intelligent assembly logic for when they recompile certain assemblies, and they're a little bit less aggressive in recompiling arbitrarily when you're in a UPM package, which theoretically will improve your development time, but mixed results on that. But
cool. Well, then let me thank you for your time and a great talk again. Thank you so much.
Thank
for
you.
the session. Maybe you can jump on Discord for more
Absolutely.
questions.
Yeah, I will definitely jump into Discord. And take a look at what's the conversation.
And I also look forward to the other sessions by your colleagues.
Yeah, definitely.
Thank you so much.
Yes. Yeah, no, thank you. Thanks for having me here. Thanks for everyone who came to watch. Thanks for Joost for your comments here, and then for everyone who's on the Discord that I'll go check out.
Thank you so much. Okay. Bye. Thank you.